Hello, I'm Andrew Monk, the Chief Executive of VSA Capital, and I'm delighted to be here today with Mark. Great to see you again, great to catch up with you again.
Lovely, Andrew, thank you for coming. And here we are stood at the bottom of our pit at Hemerdon, just on the southern edge of Dartmoor in the county of Devon in the United Kingdom.
Mark, it's always fun to catch up with you, always on site as well. And actually we're going to explore a little bit more today, aren't we, of the whole, not just the pit, but also your process plant, and we'll go around that later and understand what's been going on. But let's just start at the beginning. You floated a year ago on the London Stock Exchange. We helped you raise £40 million. It hasn't been the easiest of years, has it?
It has not. And we were this time last year. We were fully funded to execute a feasibility study that we'd put in place in 2021. We raised the money, successful float. The share price went up. Everything was looking great. But I don't think we need to tell any of our viewers and listeners today about what then happened in March. And to a large extent, actually, we got very, very lucky with not having started the build of the plant that we were planning to build at that time in the existing feasibility study. And it actually gave us an opportunity to stop and reimagine the project with a much lower energy consumption, because we were in an OPEX challenged state at that point.
Yeah, because I mean, there's two parts to this rebuild, shall we call it, of the mine. The first is obviously the CapEx, and the other is the OPEX. And I mean, you got unfortunately hit basically with both, didn't you? I mean, fuel prices and energy prices went ballistic. Even as we stand down here, you know, your dynamite prices went through the roof and that sort of thing.
I mean, we were looking at multi-100% increases in diesel, in electricity prices, in explosives prices, in steel prices, in availability of contractors. And, you know, we saw the CapEx numbers absolutely blow out. So we had no choice but to stop and to basically go through a process of engineering out as much energy consumption as we could to re-optimize the project under those assumptions, and at the same time also look at a way that we could engineer out as much CapEx as we could.
And you've obviously been going through that process, and you now have announced already that you've basically got a new plan. But are you now happy that you've got in place a new plan that actually brings this mine back into production, probably at towards the end of next year, and that you can then be profitable as well?
Yeah, I mean, that's definitely the case. So, you know, we work very close with our funding partners who do extreme due diligence on the plan that we got going forward. We've announced that we've signed a non-binding term sheet. We're working very hard to turn that into a binding term sheet and to perfect the funding package that we require to bring this mine back into operation.
Yeah, and I mean, obviously, since you announced at the beginning of the summer that you were putting things on hold and changing it, actually a lot of the other mining companies, even the big majors, have all come out and actually said they've suffered the same problems that you have. So it really is, it's not a Tungsten West issue at all. It's an entirely mining issue, isn't it?
This is a global issue, okay? Diesel prices are a global market. Steel prices are a global market. This is everywhere. And it's certainly the case that we've seen multiple mining projects put on hold, very, very few investments made to advance projects globally. And of course, the consequences of that is if we don't build new mines, we have less production. If we have less productions, we have higher prices for the products that we produce as miners.
I mean, just quickly on that pricing situation, obviously, tungsten price actually hasn't changed much in the last year. The war in Ukraine has forced energy prices up. You'd have thought with the war, you might have tungsten prices going up. I mean, there's rumours around that maybe the US Defense Department needs a little bit more tungsten at the moment. It obviously doesn't want to get it any more from Russia or China. So you must be of rather a lot of interest to people who want to rebuild their tungsten stocks.
I mean, it's been amazing. The tungsten price has been rock hard, around $340 per MTU for APT, ammonium paratungstate, which is the reference point that we use to price our products. In sterling terms, of course, with the weakness of sterling, it's actually gone up considerably this year. So that's been of a massive advantage to us. Our costs are primarily in sterling, our revenues are in dollars. And it is no doubt that we are seeing additional demand coming from the defence sector, from the oil and gas sector, areas that were in retrenchment in recent years. So I think the outlook for demand for tungsten is robust. And because of these problems of financing and building mines, the outlook for supply is constrained.
And we shouldn't forget, actually, you've also got tin as well, and the market for tin is looking really pretty healthy as well, isn't it?
Well, tin's been very, very volatile in the last 2 years. You know, we went from 13,000 on the low of the last cycle to 55,000. We've come back to 17. We're now back up around 20. My background is very much more in the tin business than the tungsten business, and I am long-term, medium-term, extremely bullish on tin. You know, we're seeing hundreds of billions of dollars of money being committed to new semiconductor capacity, and we really aren't seeing very much at all, if anything, committed to new tin mines.
So sort of in summary, you know, for your shareholders or potential new shareholders, you know, the world unfortunately did change at the start of this year. It changed for everybody. I mean, it's obviously been disappointing that your share price is now below the IPO share price, but in truth, most IPOs that were done during the pandemic or nearby are below as well. But I mean, your message really is sort of keep the faith. We're getting on with it. We're cracking on. We're going to get the mine up and running and producing, let's say by the end of 23. So just hold on in there. Is that the message?
The strategic rationale for investing in Tungsten West has not changed. 95% of the world's tungsten comes from China, North Korea, Russia and Vietnam between them. This is an increasingly strategic metal, as evidenced by the war in Ukraine and the uses that it's for. We've got a processing plant here which cost £80 million to build. We've got a pre-strip mine. We have a project which was previously robust enough to be invested in by serious financial institutions, and on our IPO by serious financial institutions. So we've been properly due diligence, the right people have looked at this, and I think this is a company with a great future in the southwest of England and beyond.
Well, I don't disagree with you at all, and your market cap at the moment is actually ludicrously low. You've only got to look around and see the size of this mine, and later when we go to the process plant, the size of that, the value embedded here is enormous. That sounds pretty good. You know what, Mark? I think it's time we went and had a look at the process plant.
Absolutely, follow me.
So Mark, we've come up here now to the front end of the whole process plant, and we're standing in front of this massive sort of what looks like a metal spin dryer or something. I think this is the bit that Wolf struggled with, isn't it? So maybe you could just explain what the problem was and how you're rectifying it.
Yeah, so this is one of the two parts of the plant which was responsible for the low recoveries that Wolf experienced alongside the refinery part of the plant. So this sits between the secondary crusher and the tertiary crusher and was designed to wash out the clay from the ore. Now, one of the great ironies of tungsten, even though it's the hardest metal there is the minerals that the ore comes from are very soft, very friable and prone to breaking down. And when you have a gravity plant, you want to keep your tungsten minerals as coarse as possible because it makes them easier to recover. So this is no longer part of the circuit. This is alongside the two big screens which were taken out of the circuit, scrap metal and of no use to us going forward.
Okay, so the whole secret really, Mark, is that you've now got these ore sorters which weren't available in the past, were they? And you can just not need this part of the process and leapfrog it from the ore sorters straight down to the rest of the process.
Yeah, that's absolutely true. We can get rid of the worst type of ore, or the non-tungsten, coarse tungsten bearing ore, with the ore sorters. The other advantage we have is the kaolinized material, the clay-rich ore, was in the top 60 metres of the ore body. And 95% of that was mined away under Wharf, leaving us stood in the pit on a base of now fresh hard granite, which has no clay in it, so we don't even need this part of the circuit.
What exactly is going on here with these machines behind us, Mark?
Yeah, so this is the first part of the concentrator circuit. This is the fines circuit, where we deal with all material which is finer than 0.8 of a millimetre. And it's an absolute classic plus 100-year-old gravity plant where we have spirals behind us and we have shaking tables. And this is a very efficient way of separating, using gravity methods, the dense and heavy tin mineral, which is cassiterite, and the tungsten mineral, which is ferberite, from the gangue minerals which make up the host rock, being the granite.
So in sort of layman's terms, it's a bit like a sieve in a way. You're sort of shaking it, and the bits that you want to come through, and the bits you don't come through.
Absolutely correct. So on the spirals, the heavies stay on the middle and the lights go to the outside. It's a great big helter-skelter, and we just then cut off the heavy bits at the bottom. And on the shaking tables, the heavies actually get kicked up the table because they take more momentum, and the lights come off the bottom and the heavies come off the top.
So a pretty sort of basic principle, but very effective.
Extremely effective. These are very, very efficient mechanisms for separating out different specific gravity minerals.
Now, also, I can see, I think they've had a splash of paint or something put on the mark. You're refurbishing the whole plant. So what is, as an example here, how are you refurbishing?
Yeah, well, it's more than a splash of paint, Andrew. Effectively, this plant was built in 2015. And because Wolf were not operating, they weren't profitable, they didn't get a lot of chance to make the upgrades and minor little alterations to the plant that you would have liked to have done in operation to make it more operable with a lower maintenance requirement. So we've had the time and opportunity to do that. We're making in excess of 1,000 small adjustments to the plant, but effectively every pipe has been inspected and replaced where required, every electrical connection, every sump, every valve, every piece of equipment has been taken apart, reassembled or replaced if required. And actually one of the other things we're very proud of that we're doing full 3D modelling of audible and low frequency noise for the whole plant and the crushing circuits outside as well, done by a specialist Australian company, which is part of our permitting process with the Environment Agency.
And presumably that reduces your operating costs as well. You can do things with more modern technology to get your costs down, yeah?
Absolutely. So we're looking for an 81% plant operation, which is 90% availability and 90% usability of that operability, is getting us to an overall 81% operation, compared to what Wolf were around, which is around 50%. And obviously if we're operating for 1.5 times, 1.6 times longer than they were, then we're much more efficient with much more lower unit costs.
All sounds fantastic. So we've done the spiralling and the shaking, and we're moving down the process. Now, what are these complicated machines here, Mark?
So this is the core of the concentrator plant. These are the DMSs. This is the dense media separator. And these are some of the most accurate dense media separators in the world. They're so accurate that they can cut to 0.003 of an SG being the specific gravity. So what we do is we create a heavy mud. So we mix water with magnetite and ferrosilicon, and we make that to have a specific gravity of about 2.7, 2.75. So in that heavy mud, the light gangue materials from the granite, the mica, the quartz, the feldspar, it actually floats. So we make the gangue rock float in the heavy liquid, and the minerals that we want, the cassiterite and the ferberite, with specific gravities of around 6, they actually sink. And then we spin it in these cyclones under immense pressure and immense gravitational forces, and the heavies go to the outside, the lights go to the center, and we can separate them out. Now, what we're doing here is we're going to use these secondaries as primaries by lifting out 2 of the bigger primaries that we have over there and replace them into here.
Okay, because this is all part of the refurbishment with a slightly lower volume going through, isn't it? That you've got, and probably if we come over here, we can see as we walk around the other machines. So which ones are you moving from there to here?
Yeah, so we've got 7 primary cyclones, got 4 duty and 3 standby. And behind us here, we've got the 2 secondaries, and just over there, we have the 2 scavengers. So we're going to lift out 2 of the primaries and put them into the cradles here, and this will become the primary. And what that allows us to do is to engineer out a lot of the energy consumption of the plant. And we can do that because those could deal with 3.5 million tonnes a year, but because of the ore sorting, and we're only feeding 1.5 million tonnes to the plant, we can get away with using 2 and not 4.
So you say you're going to lift it from over there to over here, but I mean, although it's only a short distance, it's a huge facility and a huge drop down there. Is it really as simple as just lifting it? I guess you've got a team of you that can do it, and you've got an overhead crane, have you got?
Well, I mean, not being the technical person, I'm going to say it is relatively simple because we have the crane above us, so it's something that our technical team are more than capable of doing. We have 20 people currently active in the refurbishment of the plant, and we're about 71% complete on the total refurbishment, and that is one of the tasks left to be done.
So you're saving a lot of costs, and it's obviously going to be more than sort of tens of thousands of pounds. It must be hundreds of thousands of pounds, or is it maybe even a bit more than that?
Oh, well, it's millions and millions of pounds a year, many millions of pounds a year. Look, we got very lucky as a company that when the inflation spike hit us in March, that we actually hadn't committed to a build of the previous feasibility study, because we would have been in a very difficult position if we had it done. So having taken the tough decision to pause the project, it's allowed us to completely re-engineer what we're doing in the processing plant in a way that we've managed to engineer out some 30% of our energy consumption for the whole of the company, and that's just magnificent. So in March, our diesel bill went from £3 million a year to £12 million a year, and our electricity bill went from £3.5 million to £12.5 million a year. Now they've come back down a little bit since then, but this is still a much more efficient and a much cheaper way of operating.
And also, I mean, if in the future you want to ramp up higher production, that won't affect that. You'll still be able to increase the capacity once you've done these changes.
It's a relatively minor change with a relatively short shutdown to go back to plan A, which is still at the right electricity price, the right way to go. But right now, this is where we're going for the first 2 years of operation.
Well, that sounds like a win-win situation, so sounds very good.
Plenty of optionality.
Okay, I think we're right in the guts of the operation here, Mark, and I think, correct me if I'm wrong, but we're at the kiln, the big roasting place, but I can't see much refurbishment going on. I've got this feeling you're going to give me a little bit of a surprise here.
Yeah, so this is in the guts of the refinery, and what was being fed material in here was the product that was coming out the dense media separators where we just were. So historically that was around about a 30% grade tungsten product, and the ultimate goal getting to somewhere between 50 and 60% in the refinery process. So, and that product consists effectively at this point of 4 minerals. We've got the ferberite, which is the tungsten, the cassiterite, which is the tin, and we have 2 iron minerals being hematite and magnetite. And what we want to do is get rid of the iron, and then we need to separate out the tin and the tungsten. This is what the refinery does. Now, getting rid of the magnetite is quite easy because we can use low intensity magnets, because magnetite is very magnetic, but hematite unfortunately is not. So what this kiln here does is it heats up the concentrate in an anaerobic environment, and it converts at 800 degrees C the hematite to magnetite so that we can take it off with magnets. And thereafter we then run it through high intensity magnets because the ferberite is slightly magnetic, and we can separate out the tungsten and the tin. Now, in terms of this going forward, this is the biggest consumer of power in the plant. This would consume 1.4 million litres of diesel a year. Now, with the changes that we're making to the ore sorters and the DMSs, we can actually run those harder, at higher cuts, and it means we don't need this part of the refinery at all. So this is the main saving, alongside lower tonnage coming into the plant, of cutting the energy requirement out. Now, longer term, the plan here as a phase 2 upgrade is to get rid of this pyrometallurgical refinery in its entirety and go to a hydrometallurgical facility. So we've done some test work. Admittedly it's only at lab scale so far, but this is quite an inefficient process. It's only had an 80 to 85% stage recovery. The leach work we've done shows a 98% recovery, and that would mean we would produce sodium tungstate, which is a higher value end product.
Okay, so this is all going to be removed, and you're going to bring in the leaching process here instead. And
yeah, look, subject to a feasibility study, we've obviously got to do the work, and we've got to do the work well before we make final decisions. But you know, if you run the numbers, if we go from an 80-85% recovery to a 98% recovery, we produce more product and a more valuable product. So we have the economics of it on paper so far are looking very good.
Yeah, well, that makes sense. And you know, roasting and leaching are well-known methods, should we say, in the mining industry, so there's no issues there either.
None whatsoever, no.
Mark, firstly, great view of the process plant from here. You really get a sense of the size of it and how big it is and the sunk cost of it, don't you?
Yeah, absolutely. So, very large building, as we said, £80 million cost to build by Wharf, replacement value well in excess of £120 million today. We've got the tertiary crush building here, and over in the background over there, we've got the original primary and secondary crush building, which is now redundant because of the changes that we're making to the process.
But look, what we've really come here for is what appears to be nothing at the moment, but actually this is where the secret spice is, isn't it?
Yeah, so this is where the new ore sorter building will go. So we've done the earthworks for it already, and then just behind us over here is where the new crushing circuit's going to go. So this is the bulk of the money that we are spending to turn this into a properly functioning processing plant that recovers economically important amounts of tungsten.
So ore sorters, they're a fairly new technique, aren't they, in the mining industry, but they're really vital, and that's why they weren't there before. But do you want to just quickly explain what the ore sorter does?
Yeah, so they've been around for a while, and adoption's taken a little bit of time to be fully integrated. So what the particular ore sorters we use X-ray transmission ore sorting. So we crush every rock, and it's on a conveyor belt, it's scanned by a laser, it's scanned by an X-ray, and one of the great characteristics of tungsten and tin minerals is they're opaque to X-rays, and the host rock is transparent. So if the X-rays see a valuable mineral in it, it gets accepted off the end of the conveyor, and if it doesn't have any valuable minerals, it gets rejected. So using ore sorters allows us to feed a lot less tonnage into the processing plant, and obviously processing material is very expensive, so we can save an enormous amount of money by processing all of the ore through an ore sorter.
And how many ore sorters are you going to put here?
Yeah, so we bought 7, which is what we needed for the original feasibility study, which was 6 duty, 1 standby. And the new plan, because we're starting with a slower ramp up, we're putting 4 in to begin with, and that will get increased to 5 or maybe even 6 on the phase 2 expansion.
Okay, and obviously with this ore sorting, presumably you get actually a whole load of rock of that sort of size that doesn't go into the process plant. That's going to go to your aggregates, is it?
Absolutely. So what we reject from here, and at the moment this rock here we stood on is Killus, which is the country rock. The valuable aggregates come from the granite, and they produce really nice single sizes and sands, etc. So we can produce almost the entire suite of aggregate products, much of which we've now had accepted as specification for highway works. So we've got a really good local market to be selling what otherwise would be waste, is now actually environmentally friendly secondary aggregates coming from here to feed into the local market.
And is that the sort of the last bit you put in the ore sorters, or will it, because they're quite expensive kit presumably, or is it the first bit you can put in?
It's all going in together, so there's going to be a vast amount of construction going on at one time, and our team will be managing that process alongside our EPCM contractor.
So next year is going to be a busy year all over the place.
It's going to be busy here. It's going to be a busy site, and because we have the value of the existing plant, it's a relatively easy build as mining goes.
Sounds fantastic. So Mark, we're back where we started, back in the pit, but that was a great tour of the whole mine, the process plant, etc. It's fascinating that what is clear is you are getting on and doing things, and that work is taking place, and you're getting there. You must be pretty excited. Yeah,
I think it's fairly evident, you know, from your and thank you for coming, by the way, for today. It's fairly evident. You can see where we're spending money. You can see the equipment we're buying. You can see the progress that we've made. We are very close now. Just perfect the financing package. Start the construction, put the ore sorters in, and then we're raring to go.
And you've basically got 2 valuable businesses, haven't you? You've got this fantastic tin and tungsten mine, and you've got this fantastic processing plant. Put them together, it's an amazing project, and it's an amazing project for the southwest of England, isn't it?
I think so. I think this is not just important for the southwest. I think it's nationally important to have such a large deposit in the UK, such a strategically valuable mineral, to have such an economically viable mine as well. And I think this is also internationally important because of the dominance of the countries in the world that currently produce tungsten.
So one final question for you. You got Liz Truss down here in the summer. Are you going to get Rishi Sunak down here?
He's more than welcome at any time.
If he comes down, I'll come and join you.
Perfect.